Now let's talk a little bit about actually finding these potential functions. Now we know that this vector field is a conservative vector field because basically we just showed it. But I want to find a potential function f such that f equals the gradient of f. And once I have that, life becomes pretty nice in terms of being able to integrate some of the line integrals here. Now, what do we have here? Now we know that the partial of f with respect to x has got to be 2xy minus z squared. It's right here. Okay, that gives me the component in terms for the gradient. So in other words, that's going to then imply that f is going to equal, I need to integrate this, 2xy minus z squared with respect to x. And when I do, I'll get x squared y minus z squared x plus, I'm going to end up with some function g of y and z. This is what I'm thinking of as my constant of integration, because I have an indefinite integral that I'm working with here. Now what I want to do is I want to take the derivative of this with respect to y. I'm going to take the partial. And I know when I take the partial of this that it has to be equal to this component right here. So right now I'm saying I know that f of x, y, z is going to look like x squared y minus z squared x plus some function of y and z. I just need to determine what this is. So the partial of this with respect to y is going to give me x squared, what's this, x squared, plus g prime of yz. So when I take this and I compare it up here, it's pretty clear that g prime of yz has to be 2z. So this would then give me g prime of yz has got to be 2z. So now what I can do is I'm going to go ahead and integrate this. I'm going to integrate 2z with respect to y, dy, and I will get 2zy plus my constant of integration, which is going to end up being, I'm going to call it h, some function of z, my other leftover variable. So what do I have so far? If I put all these together, I know that f of x, y, z has got to be equal to x squared y minus z squared x plus, what do I have here? X squared plus, no, wait a minute, that x squared is not there. This is just my plus 2zy. The x squared came from this term right here, plus some function of z. So right now I know that this is what this function f has got to look like. The question is, what's this function of z? So of course the next thing I'm going to do is take the derivative of this, a partial, with respect to z. And when I do that, I'm going to get a negative, what do I have? 2xz from here plus 2y plus h prime of z. Now when I look at this, compare it up here, here's my 2y, here's my negative 2xz. So that tells me that h prime of z must be equal to 0, which implies h of z equals some constant k. And I'm going to simply take k to be 0. Because here, it really doesn't matter, because what I'm saying here is that I now have my function f of x, y, z, which is going to be, see, x squared y minus z squared x plus 2 zy, and I'm going to just toss on here, plus this constant k that we got rid of right there. Now, this k, the reason I said I could take it to be 0 is because this is all about being able to find the gradient function. So to find the gradient, I'm going to take the partial with respect to x, y, and z. So every time, this k is not going to contribute everything. It's going to be 0 every time when I take the partials. So I can just drop that k and not worry about it. So this function f of x, y, z is accurate to within some constant function, which the value of which is totally irrelevant because it doesn't change anything that I'm doing. So what I have, this last statement basically I want to make based on all this, is that my vector field function, I'll go right as a vector, is 2xy minus z squared, x squared plus 2z, 2y minus 2xz. This is the vector field I was originally given. This equals the gradient of f. And this is the f that I just found. And the gradient of f is obviously equal to the partial of f with respect to x, I. When I take that partial, this is what I get. Plus the partial of f with respect to y, j. When I take that partial, this is what I get. Plus the partial of, the partial of f with respect to z, k. When I take that partial, this is what I get. So I was able to find f, the potential function, or a potential function, because they differ by this k.